In May 2015, the concrete and construction industry will be changed forever. Make a date with innovation. Make a date for African construction and Totally Concrete Expos.
Okay, at the University of Pretoria we've got a 150G centrifuge, which means you can put a ton of materials and spin it up to 150 times Earth's gravitation. It is the biggest centrifuge at the moment in the Southern Hemisphere. Why we're using it is if you have soils, the deeper you go below the soil, the more the stresses are, and you lose that when you have a small model. You can't have the own weight of the structure there. So if you want to have the realistic behavior of ground, you have to either do full-scale testing, which is very expensive, or you need a geotechnical centrifuge. So what we can do is if I build a model and I build it to 1/50th the size of a normal structure, I could spin it up to 50 Gs in the centrifuge, and then the stresses in the soil would be similar to the stresses in real life. One of those big spin-offs to me has been when we looked at the ultra-thin pavements. You can test it full scale and it costs a couple of million rand per kilometre or per test section. Here we can build a small scale model and do a lot of, we can vary variables, which you can't do if you have to build things full scale. So we've been looking at footings and different stiffnesses of footings, which has not been done in the country before. And we've also been able to model pavements, having vehicle axle loads running across the pavement and looking at the stress distribution in and under the pavement, which is also not possible to do full scale outside. You always have rain, you've got varying temperatures, you can't control the environment, which we can do in the centrifuge. So one thing we've been looking at as well is rehabilitations of mines. If you, for instance, have an open cast mine, for instance, where you take the aggregate for concrete out, afterwards you have to by law rehabilitate it, and if you throw the material back into this big open pit, it settles. And we've been looking at how does it settle, can we predict how it will settle, and what can be done to minimize the settlement, because afterwards you're actually building a big dam where the water collects in the middle of the old mine. So for rehabilitation purposes, we've also been modeling what happens when you've got a pit that's open and you backfill it with different types of materials. Up to now, our challenge has been just getting off the ground, getting to know it, starting up experiments that have a practical application. And I think that's the challenge for the future, is to get industry to support us and to get us up to the point where our results can really be proven with full-scale testing. So if we could model, for instance, if they're expanding the Gou train, could model some of the effects of a tunnel under existing buildings and prove it by instrumenting it in the field. Or what we're doing currently with the ultra-thin pavements, having a scale model in the centrifuge and then linking it back to experiments that's done full scale in the field to calibrate our results. It's great fun. Having something that's world-class rare really places us in a different league, so we really can now compete with the good international universities in terms of research.